Hello again, ladies and gentlemen, and welcome to the first tutorial that we were going to have some problems which are kind of related to lecture 2 and lecture 3. I am going to solve some problems which are from the problem sheets. So let's begin with problem sheet number 1. I'm going to look at problem number 3, and the question is number 5. What is happening? There's a beam like this. There's some loads on it, let's say 50, let's say 100, and let's say 60. They're all spaced at 2 meter, 2 meter, 2 meter, 2 meter. There is P here, there is Q here, and there is R here. So the question is asking us to figure out what are the unknowns. As you can see, we have the known loads, 50, 100, 60. We have the distances of these loads. We have a beam. Yeah, and then the loads which are unknown are R, P, and Q. Now, if you compare this to a simply supported beam as well, if you remember, whenever we were saying let's have a simply supported beam, we meant that some location will be a pin and the other location will be a roller. So let's say pin and roller. And then if you remember the reactions for these, the reactions for this was this. It didn't allow it to go left and right, it didn't allow it to go up and down, and the roller was only a reaction like this. It didn't allow it to go up and down. So now if you compare this, and let's assume that these red arrows are the unknowns to this case, isn't it very similar? Yeah, you see? Okay, the arrow of R is the other way around, but we know that it really doesn't matter. Okay, let's have that. And yeah, let's solve it. So the question is saying that figure out what is the unknown forces R, P, Q, and Q in a way that the equilibrium will be satisfied. Again, if you remember, we were saying equilibrium is when these three equations, summation of all forces in X direction, summation of all forces in Y direction, and summation of all moments along a point will be 0. Then our building is at rest and is stable. Yeah, so let's write these equations for this, and let's get help from these equations to figure out what is R, what is P, and what is Q. So the first equation, summation of all forces in X direction equals to 0. As we discussed, we always tend to have an assumed direction of positivity. Let's assume it's like this. So any force going from left to right is positive. Let's solve this. Looking at these forces, which one goes from left to right or right to left? There is R, and then we have this force. Let's divide this to its components. So the question says over here is 45 degrees. If I draw the components of this force, there will be one force like this and there will be one force like this, which both of them are applied at this point. Yeah, so the components will be applied at that point as well. Now, if this is 45 degrees and this is 90 degrees, then gives us this angle as 45 degrees as well. Having that 45 degrees, I can easily write the components of these forces. So this will be 60 times cosine of 45 degrees, and this will be 60 times sine of 45 degrees. This is a discussion we had in lecture 2 and how we divide one angled load into two components, which then we can deal with it in our 2D environment. Yeah, so it's angled, but I can divide it into components, and the resultant, trust me, will be this 60 Newton or kilonewton load which is applied at this point. Yeah, now so this 60 is now gone and it's replaced by these two forces. Now looking at this the same beam, now I have this load which is in X direction as well as this force in x direction. Both of them are against my positive direction. So let's write them. Negative r, because it's against my assumed positive direction, minus 60 times sine of 45 degrees. Is there any other load which is in x direction? No. So I just put equals to 0. Having this, can I solve it to figure out what is r? Yes. R, or let's say negative r, is equal to 60 sine of 45 degrees, or r equals to negative 60 sine 45 degrees. So r is now figured out. I'll keep it as sine and cosine for now, but you can simply use your calculator to calculate them as well. R is done, so 1 is gone. We have P and Q. We have still 2 equations left, 2 unknowns, so we are in a good position. Let's go to the next one. Summation of all the forces in y direction equals to 0. I assume a direction for positivity. I always assume a direction from going from the bottom to the top as positive. You're more than welcome to assume your own direction, but trust me, it's better to keep the standard that everyone uses. Now, let's move from the left side all the way to the right side and write all of the forces which go from the bottom to the top. P, and it's in the same direction, so positive P. 50, which is negative because it's coming from top to bottom, while my direction is the other way around, so minus 50, minus 100. Why minus? Again, because it's against the direction that I have assumed. I'll just say assumed positive direction. Yep. Minus 100, and then there is this guy as well, which is again going from top to bottom, so minus 60 times cosine of 45 degrees. And then we have Q, which is going from bottom to top, so plus Q equals to 0. I can simplify this, and I can see that there are P and Q which are unknown. But this is just one single equation, so I cannot solve it for P and Q like this R that we did. So I'll continue. I have another equation left. Let's write that as well. To 0, and I assume this direction, any moment going like this, is my positive. This is where it gets tricky a little bit. Do you remember what moment was? Each time you want to write the moment, I remind you of this. That if I have a hand and I apply a force, and this wrench is trying to open a pin, this force, because it has a perpendicular distance to that pin, it will generate a moment in that direction. Yeah, so this is applied as a load going down, so it goes like this, and because of that, a moment is generated. The same thing happens over here as well. Any force that you see here, if I assume it against a certain point, let's say point A, as long as there is a distance to that point, it will generate a moment and in that point, because there is a perpendicular distance. Look at 50 and point A. This 50 will be this force that we have here. This distance will be these 2 meters, and point A will be my pin. So 50, if M is force times displacement, so 50 times that 2 meter will give me the moment. Now, against that point, let's assume that this point, this pin is point A. Yeah, similar to this. If I put it against this point and I apply the force like this, what is the direction that goes? Isn't it clockwise? Yeah, so 50 goes down and around A, around A, around A. So it's clockwise. So it will be, because I have assumed clockwise as positive direction, it will be plus 50 times the distance that it has. I just put the meters here so I know that this is my distance and 50 is my force. Let's look at 100. 100 going around A, as you can see, it will generate a positive moment with my direction, a clockwise moment. So it's plus 100 times its distance. Now the distance is 4 meters. 2 and 2, 4 meters. What about here? Over here I have this force, 60 cosine of 45 degrees, which is parallel to these 100. So let's put that as well. And because it's going from top to bottom, going around A is clockwise. So it's plus 60 times cosine of 45 degrees times the distance that it has, 6 meters. Remember, although I have put the force over here, but these are resultants of this force, so they're getting applied over here. So you have to measure their distance from here all the way to here. So times the 6 meter that it has. There's another force left as well, Q. But now pay attention to Q. Q going around A, because the direction is opposite to these guys, it goes anti-clockwise if it's applied to A. So it's negative Q times its distance, which is 8 meters. Do I have other forces? Yes. I have R, I have 60 sine of 45 degrees, and I have P. But is there any distance between P and point A? No, there is no perpendicular distance. The distance is 0. So if D is 0, then the entire moment generated by that force is 0. Is R, there is any distance between R and point A? No, R is applied at point A. So again, the distance is 0. So the moment generated by that is 0. The trick comes when we look at this. This force is applied at this point. And this point, there is no distance to this point A anymore perpendicular. Okay, you can argue that there is few millimeters over there, but millimeters compared to the 2 meter that we have over here is negligible. So like that force, which is parallel to R as well, will not generate any moment at point A. So I can say this is equal to 0. Having this formulation, I can simply calculate Q. Having Q, because it's one equation, one unknown, I can replace it over here. And then having Q, again, I have one equation, one unknown, so I can figure out P. And I have already figured out R, so I have calculated all of the 3 unknowns satisfying the equations of equilibrium, meaning that the structure will be at rest, it will not fly away, it will be stable. Yeah, and again we discussed that looking at this, it is kind of similar to the reactions that we get at a simply supported beam. And each of these forces are an actual thing. So this can be the washing machine, this can be the elephant, which is like sitting a little bit inclined, and this can be a human being. But replacing all of those loads with some simplified arrows and simplified numbers with proper units as well, we call this free body diagram, or FBD. Let's look at another case. Let's make it a bit more sophisticated. So now I'm in problem sheet 1. I'm in problem 3. And I'm in question number 6. It's beside the other one. It's a box. So let's draw a box. I put points, 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 points. Why do I say it's a box, it's not a frame? Because usually a frame doesn't have this bottom bit, but really doesn't matter as long as you know what you're doing. So let's call these guys as well. A, B, C, D. I'm just naming them. You can call them Alex. Doesn't matter. some load is applied here, 60, probably it has a unit as well. For now, I don't care about the unit, but you have to make sure that you know the unit because the forces that you will calculate will be based on that unit. P, Q, there's a R force applied here. There's a force applied to the middle of this member, which is 50 kilonewtons. So let me just put the units as well, why not? And then there is one force applied here as well, which is 40 kilonewtons. This is applied to the middle, so 2 meter, 2 meter. And this one is applied to the middle as well, 2 meter, 2 meter. This distance from here to here is 4 meter. Yeah. Again, it's asking me to calculate in a way that the box or the frame is at rest, and equations of equilibrium, which were summation of all forces in x direction equals to 0, summation of all forces in y direction equals to 0, and summation of all moments along a point will be 0. As you saw in the previous one, that along a point, I selected a point and I called it A, and I got moment around it. You're more than welcome to get moment around anything. It will be the same thing. The system of calculation works in a way that moment along any point will be 0. Okay. And it's saying, okay, figure out what is R, what is Q, what is P, which these are our unknowns. Again, if this is the box and I just put it like this on a pin and a roller, wasn't this a reaction like this and a reaction or a resistance like this, and because of the roller only a resistance like this? Isn't this similar to these unknowns that we have? Yes, I just remove these and I just replace them by forces. This is what we will do from now on. From now on, instead of putting P and Q, you will see the pin and the roller. And immediately, as you saw the pin and the roller, you will replace them with the forces P, Q, and R. Now, let's solve this. Why not? So again, summation of all the forces in x direction equals to 0, and I assume this direction as positive. What do I have? I have a P here, and it's in the same direction as my positivity. So P. I have a 60 kilonewton here, so let's say plus 60. And I have a 50, which is against my direction of positivity, so minus 50. Is there any other load in x direction? No, so I just put equals to 0. Again, I'm putting my 0 sometimes like this, sometimes like that, so don't be confused, it's 0. Now, can I calculate anything from this? Yes, I can say P is 60 minus 10 kilonewtons. What does that minus mean? That minus means that initially, when I assumed the direction of that force, I was wrong. In reality, the direction of this force is not from left to right, it's from right to left. But, as a suggestion, some people change that force, put it the other way, and start calculating. I suggest that you keep it as it is and just know that that's negativity means the direction assumed is wrong. Just know that and put this note beside it. As simple as that. I suggest that you don't change it, but again, you're more than welcome, and so many people change it as well. There is no right or wrong in this case. As long as you know that what that negativity means, it doesn't mean that it goes inside or it comes outside. It's just this direction is actually this direction. I just remove this so we don't get confused. Okay, 1 done. So let's say P is done. 2 to go. How many equations do I have left? 1 and 2. I have 2 unknowns as well, so I should easily be able to solve it. Now, let's say summation of all forces in y direction equals to 0, and going from bottom to top is 0. Now, Q is going from bottom to top, so it's positive. This guy is coming down, so it's negative 40. and this guy is going up, so is positive, equals to 0. One equation, two unknowns, so I need another equation as well. What is left? Summation of all moments along one point equals to 0. That point, from now on, I suggest you select that point at a place that you have majority of your unknowns. Looking at A, I have two unknowns, so A is the best place to select that point. So I'm going to write all of the moments which are resultant from those forces applied. Here the wrench is back. Force, displacement perpendicular will cause a moment, which that moment is force times the displacement. Now, again, I have selected a point, which is A. Why did I select that? Because it has majority of unknowns, so I can get rid of them. Although I have actually calculated what P is, but trust me, this will make your calculation easier. Now, let's see what forces will generate a moment toward point A. Remember, there should be a perpendicular distance from that force to that point, which is currently point, let's say, A. Let's see. Doesn't this guy have a distance perpendicular to A? Yes. What is the distance? 4 meters. If I follow the force of 60 kilonewtons around point A, it will generate a moment like this. Isn't this clockwise? Yes. So it's a positive 60 times the distance, which is 4 meters. What about PU and Q? P and Q, as we discussed like in the previous one as well, the distance from them perpendicular to A is 0. So if the distance is 0, the whole moment is 0. So I can ignore these two. Now look at 40. 40 is the other way than 60 kilonewtons, but it has a perpendicular distance to point A. Yeah, so if I put 40 over here, there's a perpendicular distance. So what happens is 40, if it goes around A, it will have a clockwise rotation, so it will generate clockwise moments. So it's plus 40, because clockwise was positive, times its distance is 2 meters. Let's look at 50 and you'll understand that fully. So look at 50. Following point 50, the arrow of 50, and going around A, as you can see, my movement of my pen and hand is anti-clockwise. So it's negative 50 times the distance that it has perpendicular to that point. You see, if I look at this distance perpendicular is 2 meters times 2 meters. There's another force as well which has a distance perpendicular all the way to that point A. Similar to this 60 kilonewtons perpendicular, there's an R here as well, so which is 4 meters as well. If R, we follow the arrow and we go around A, again, as you can see, is anti-clockwise. So it's minus R times the 4 meter and equals to 0 because I don't have any force left. I said we get rid of P and Q because they don't have any distance to A. I can't measure any distance. But R, a perpendicular distance, 50 kilonewtons, a perpendicular distance, 40 kilonewton, a perpendicular distance, and the 60 kilonewton, a perpendicular distance. See, over here and here, I have a perpendicular distance. Over here and here, I have a perpendicular distance. And always assume this, even if they're from the space and they have a different distance from each other, for example, like this or like this, you just look at the perpendicular distance regardless. Now, having this, I'm sure simply by using a calculator, you can figure out what are these values. Then R will be generated. Putting R in this equation will generate Q, and you have already generated P. So P is done, R is done, and Q is done. As simple as that. As long as the values of P, Q, and R are the values that you have calculated, this structure will be at rest. Well done, you have designed your first box or frame which is at rest. So if these loads are applied, it won't fly away. What are these loads that you can see here and here and here? For example, let's put it on this. This 60 kilonewtons can be the wind. This 40 kilonewtons can be the washing machine. This 50 kilonewtons can be, I don't know, the earthquake. So, as always, the forces that are applied to my structure are always known. The red ones are always known. What is unknown is the reactions. I can measure how heavy the washing machine is. I can measure how strong the wind or the earthquake is going to hit my building. Then, according to that, I measure the reactions that I have to have. And then as long as these reactions and these supports, let's call them, are designed in a way to withstand those applied loads, my structure will be at rest and I will have a very stable building or a very stable bridge. And you have done your job as a structural engineer.